Now I will be moving to the exercise, that is exercise 11.2. Move to exercise 11.2. Here 11.2. So your first question is, so that the three lines with directions cosine are mutually perpendicular. Your first question is exercise 11.22. Your first question is, you have to show that these directions cosines are mutually perpendicular. That means L1 L2 plus N1 M2 plus N1 N2 is equal to 0. So here directions cosines are given. So this is 12 by 13 into 4 by 13 plus minus 3 by 13 into 3 by into 12 by 13, sorry. Next is 12 by 13 plus minus 4 by 13 into 3 by 13. So here now if you calculate it, you will get, this is 44 to the 48 by 169 plus 36 by 169 plus 12 by 169. Sorry, these are minus. So this is 6, 7, 8, 48. So 48 by 169 minus 48 by 169, and this is equal to 0, which proves that the two lines are perpendicular. Now I am moving to question number 2. Question number 2 here. Moving to question number 2. You see that question number 2. So that the line through the point this and this is perpendicular to the line. So here the points are given, that A point 1 minus 1 2, and your B point is given 3 4 minus 2, and there is another C which is 0 3 2, and this is 3 5 6. This is D. So you have to show that these two line passing through these points and these points are perpendicular to each other. So I'm showing one thing, that is y, x and z. This A point 1 minus 1 2, and this is B point, that is a B point, and this is 3 4 minus 2. So this is your position vector A vector, and this is your position vector, this is your B vector, and this is AB. So here you see, that means if you have to find AB vector, your AB vector, that will be equal to B vector minus A vector. So I have already told you, that means B vector, these are the coordinates, so this will be what, 3i cap minus plus 4j cap minus 2k cap minus, this is I cap minus j cap plus 2k cap. So here this is AB vector. So your AB vector, this is AB vector, that is equal to 3 minus 1, this will be 2i cap, and 4 minus 1 plus 5 j cap, and minus 2 minus 2, that is minus 4 j cap. This is how we find AB vector. But in short, what you have to do, AB means the 3 minus 1, 4 minus this, 2 minus. Similarly, your CD vector, this will be 3 minus 0, 3i cap, 5 minus 3, that will be 2j cap, and 6 minus 2, that will be minus 4k cap. So these are, we have to show that these are perpendicular. Remember one thing, that here when nothing is given to you, then these are the directions ratios, these are the directions ratios. So if they are perpendicular, the condition is A1 A2 plus B1 B2 plus C1 C2 will be equal to 0. So this is 3 to the 6 plus 2 5 the 10 minus 4 4 the minus one thing minus, and this is minus. So 6 minus 6 minus 2, this is 4 plus 4. 6 minus plus 4. So this is minus 16. So here it comes out to be 16 minus 16. This is equal to 0. So these two vectors are perpendicular. So remember how to find AB vector. So in short, you have to find AB vector, then B coordinates will be at first 3 minus 1, 4 minus, and CD similarly 3 minus 0, 5 minus 3, and 6 minus 2. So now next question is question number 3. You have to show that this is question number 2. Now question number 3, and you have to show that these are parallels. So parallel, in the same case for parallel, the condition is A1 by A2 will be equal to B1 by B2 equal to C1 by C2. This is the condition of parallel condition. So 2 points are given here. So here let us consider A point, and that is 4, 7, 8, and your B point, that is 2, 3, 4. Another your C point, that is minus 1, minus 2, 1, and your D point, that is 1, 2, 5. So here you see that your AB vector, that is equal to 2 minus 4 minus 2 I cap, 3 minus 7 minus 4 j cap, 4 minus 8 minus 4 k cap. And your CD vector, that is 1 minus minus 2 I cap, that is 2 minus minus plus 4 j cap, 5 minus, and that is plus 4 k cap. So here you see that A1 by A2, that is minus 2 by 2, minus 4 by 4, minus 4 by 4, and so these all are minus 1, so it is equal, so they are parallel. So they are parallel. Now the next question, question number 4. Here your question number 4. Find the equation of the line passing through the point this and parallel to the vector this. Now question number 4, that is find the equation of the line, find the equation of the line which passes through which passes through the point 1, 2, 3 and is parallel to the vector 3 I cap plus 2 j cap minus 2 k cap here. Now you see that I am drawing the graph, that is here this is y, this is x, and this is z. Passing through this point here, this is the point, that is A 1, 2, 3, and this vector is parallel to this B vector, and this your B vector is 3 I cap plus 2 j cap minus 2 k cap. So the equation of the line in vector form, this will be R vector is equal to A vector plus lambda B vector. So your A vector, this is your position vector, this is your A vector. So this A vector, R vector, will be equal to A vector, that is I cap plus 2 j cap plus 3 k cap plus lambda, and B vector is 3 I cap plus 2 j cap minus 2 k cap. So this is your answer in vector form. You can write this in Cartesian form also. In Cartesian form, it will be x minus 1 by 3 is equal to y minus 2 by 2 is equal to z minus 3 by minus 2, because these are the directions of the b vector, and this is the point 1, 2, 3. These are the point. So you can express in Cartesian form also. Either this you can express in this form or you can express in this form. So now question number 5, Here question number 5 again. You see exercise 11.2 question number 5. Your exercise 11.2 question number 5. Question number 5. Find the equation of a line in vector and Cartesian form that passes through the point with position vector this and is in the direction. You have to express in Cartesian form. The question is that find the question number 5. This is question number 5. Find the equation of the line. Find the equation of the line uh, in vector form and in Cartesian form. In vector form and in Cartesian form. In vector form, in Cartesian form, that passes through the point that passes through the point which passes through the point with position, that is position vector. It is given a vector, it is given to you, position vector 2 cap minus j cap plus 4k cap and is in the direction of I cap plus 2j cap minus k cap, in this direction. So here you see that you have to find the equation in Cartesian form as well as in vector form. There's nothing. You can see this, your graph y, x, z. So this line, your position vector a, this a vector, it is given to you. Your a vector is 2 cap minus j cap plus 4k cap, and your b vector, it is given to you, that is I cap plus 2j cap minus k cap in the direction. This is b vector, it is given to you. So in vector form, it will be r vector is equal to a vector plus lambda b vector. So this will be r vector will be equal to 2 cap minus j cap plus 4k cap. This is 4k cap plus lambda, and your b vector is I cap plus 2j cap minus k cap. This is the vector form. And if you have to find it in scalar form, this Cartesian form, so this will be x minus 2 by 1, y minus 1 plus 1 by 2, and z minus 4 by minus 1. This is the Cartesian form. Now let me check the answer. Question number 5, 11.2. 11.2. Your 11 question number 5. This both are correct. So this is all. Now question number 6. Here I am going to question number 6 again. Question number 6. Question number 6. This is question number 6 here. Question number 6. Find the Cartesian equation of the line passing through this point and parallel to the line. Here it is given. You have to find the equation of the line which is passing through this point minus 2 comma 4 comma minus 5, and it is parallel to this b vector. That is b vector is given as x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6. This is given, means it is given here. Find the Cartesian equation of the line which passes through the point, it passes to the point minus 2, 4, minus 1, minus 5, and it is parallel to this given vector. So you have to write the Cartesian equation. So directly you can write it here. X minus minus means plus 2, and this is A 3, that is y minus 4, and this is your B 5, and equal to y minus 4, and this is Z minus plus 5 by this is your C. So this is your answer. You can directly write the answer. Question number 6. Let me check the answer. Question number 11.2, question number 6. Answer is correct. This is 4. Question number. This is correct. Now question number 7. See question number 7. Here in question number 7, you see this. In question number 7. Question number 7. Here the Cartesian equation of a line, Cartesian equation of a line is x minus 5 by 3 is equal to y plus 4 by 7 is equal to z minus 6 by 2. We have to write it in vector form. This is very easy. This is your A, B, C, and this is your A, coordinates of A point. The coordinates of A point is 5 minus 4 and 6, and your this B vector is 3i cap plus 7j cap and plus 2k cap. So here your R vector is equal to 5i cap minus 4j cap plus 6k cap plus lambda. Your B vector is 3i cap plus 7j cap plus 2k cap. So this is your answer. Directly you can write the answer. Now question number 8. Question number 8. Here, see here question number 8. Here here it is given, that is the equation, vector and Cartesian equation of a line which passes through the origin. That means origin, your coordinate is 0 0 0, and another point, that is the A point, which is 5 comma minus 2 comma 3. So here Cartesian is very easy. This is x minus 0 by 5 is equal to y minus 0 by minus 2 is equal to z minus 0 by 3 minus 0. This is 3. This is the Cartesian form. And then x2 minus x1. And in vector form, that is equal to R vector is equal to A vector plus lambda B minus A vector. So here R vector, this is all 0 vectors, and so remaining lambda B minus A, that is 5 I cap minus 2 j cap and plus 3 k cap. This is the vector form of your equation. So let me check the answer. Question number 8. Question number 8, R vector this, 5 this, and this is the answer. It is correct. Now question number 9, that is find the vector and Cartesian equation of the line that passes through the points 3 comma minus 2 minus 5 and 3 comma minus 2 6. So here this is very easy. Everything is given to you. In Cartesian form it will be x minus 3 minus 3 0, then again y minus minus plus 2 minus 2 minus 0, that is again z minus minus plus 5, this is 6 6 this is 6, 6 minus minus, this will be 11. So this is your answer. So this is in Cartesian form. So let me check the answer in question number 9, 11.2. 11.2, 11, question number 9. It's correct, and its vector form, it is nothing but in vector form. This is your a vector and b minus a. This is your a vector. Your a vector is 3I cap minus 2j cap minus 5k cap, and your b vector is that is 3I cap minus 2j cap plus 6k cap. So if you place this value, r vector is equal to a vector plus lambda b vector minus a vector. So your a vector, this r vector, your a vector is 3I cap minus 2j cap minus 5k cap, and this is lambda b minus a. This will be 0I cap plus 0j cap plus 11 k cap. This is your vector form. This is your answer. So let me check the answer. Question number 9, 11.2, question number 9, 11.2, question number 9. It is correct. Now question number 10. These are all very easy questions. So question number 10, here you see question number 10, that is you have to find the angle. The two equations are given. R is equal in vector form 2I cap minus 5j cap plus k cap, and plus lambda, that is 3I cap plus 2j cap plus 2j cap plus 6k cap, and another vector R, that is a 7I cap minus 6k cap plus some constant, that is I cap plus 2j cap plus 2k cap. So here to find the angles, we are not uh, this a vector, a1 and a2 vector, it does not play any game. This only this b1 and b2 vector, these two vectors b1 and b2 vector. So cos theta will be equal to this a1 a2 plus b1 b2 plus c1 c2. This will be 3 plus 2 to the 4 plus 6 to the 12 divided by root over, this is 3 square plus 2 square plus 6 square, and root over 1 square plus 2 square plus 2 square. So 7 7 8 9. So this will be 19 divided by 9 plus 5 plus 11, 9 plus 4 6 6 are 36. So this 10 9 4 49. 49 means 7, and again this will be 4 plus 4 8 1 9 into 3. So this is 19 by 21. Let me check the answer. Question number 10, 11.2. Question number 10, it's okay. Theta will be cos inverse. So here theta will be equal to cos inverse 19 by 21. This is your answer. So now again question number 11. Here question number 11, you see that question number 11. Question number 11, here you see that angle between, again you have to determine the angle, but it is, the question is given in Cartesian form. Earlier it was given in vector form. Here this question is given in Cartesian form, and z minus plus 3 by minus 5, minus 3. Cartesian form, that is x plus 2 by minus 1, y minus 4 by 8, that is z minus 5 by 4. So we have to find the angle. So here it is clear that your b1 vector, that is equal to 2 I cap plus 5j cap minus 3k cap, and your b2 vector, that is equal to minus I cap plus 8j cap plus 4k cap. So here cos theta will be equal to this will be b1 dot b2, that is minus 2, 5 8 are 40 and minus 12 divided by root over 2 square plus 5 square, 5 square plus minus 3 the whole square, root over minus 1 the whole square plus 8 square plus 4 square. So this is comes out to be 40 40 minus 14, this is 6 3 26, so this will be 26, and here 2 square, that means 2 square, this is 4 4 plus 25 9, so this becomes 9 this is 34 38, so this is root 38 and 9 because 9 5 25 and 4, so 13 here you say 25 plus 13 5 6 7 8 38, and this here uh, this is 1 plus 8 is a 64 and 16, so 10 11 6 7 1 81, so this is 81 81, so 38, when we factorize 38 what we get 38 2 1 are 2 2 9 are so 81 9 9 is 81, so this will be 26 by 9 root 38. Let me check the answer. Question number 11. Let me check the answer. 11.2. Question number 11. It's okay. So this is it's okay. So your theta will be equal to cos inverse 26 by 9 root 38. Now question number 12. I am going to question number 12. How to solve this question number 12. Here question, find the value of p. They are given that they are perpendicular to each other. Question number 12. But the format is in Cartesian form, minus x by 3 is equal to 7y minus 14 by 2p is equal to z minus 3 by 2. And another equation is 7 minus 7x by 3p is equal to y minus 5 by 1 is equal to 6 minus z by 5. So now first of all you have to make some arrangement, that is you have to set this like x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. You have to set like this. So this first equation, this will be x minus x1 by minus 3, minus 1 is common. In your second, this will be 7 common, so y minus 2 by 2p by 7, and your third is z minus 3 by 2. This is correct, z minus 3 by 2. This is correct, this is 2. So in this here again minus common, so x minus 1 divided by minus 3p by 7 is equal to y minus 5 by 1 is equal to z minus 6 by minus 5. You have to first set like this. So here your b1 vector, this is your b1 vector, this is equal to minus 3i cap plus 2p by 7j cap plus 2k cap, and your b2 vector, this is minus 3p by 7i cap plus j cap minus 5k cap. So see this, since these two vectors are perpendicular, so b1 b2, so a1 a2 plus b1 b2 plus c1 c2 is 0. So this is 3 into 3p by 7 plus 2p by 7 into 1 and minus 10, so this is equal to 0. So this is 9p by 7 plus 2p by 7 is equal to 10. 11p, this is equal to 70. So p is equal to 70 by 11. This is your answer. So let me check the answer. 11.2, 11.2, 11.2, 70 by 11, it is correct. Your question number 13 is in the same like question number 12. Now question number 14, I am going to question 13 is same like question number 12. So you can do it yourself. Now I am going to question number 14. So to solve question number 14, shortest distance, that means q lines are given. So here question number 14, here r vector that is equal to I cap plus 2 j cap uh, plus k cap and plus lambda, that is I vector minus j cap plus k cap. This is, and another equation of the line, it is given r vector that is equal to 2 I cap minus j cap minus k cap and plus this is equal to 2 I cap plus j cap plus 2 k cap. So this, so here shortest distance, you have to use the shortest distance formula. Shortest distance formula. So your shortest, I'm going to use the shortest distance formula. Your shortest distance formula is d is equal to b1 vector cross b2 vector dot a2 vector minus a1 vector divided by modulus b1 vector cross b2 vector. So here you see that your b1 vector and b2 vector, these are your b1 vector, this is your b1 vector and this is your b2 vector. So cross b2 vector, we will take the help of determinant. So this is I, j and k, k cap, 1 minus 1 1 and this is 2 1 2. So here this is I cap minus 2 minus 1 minus j cap, this will be 2 2 minus 2 and plus k cap, this will be 1 minus minus plus 2. So this is minus 3 I cap minus 0 j cap and 3 k cap. So this is b cross this is b1 vector cross b2 vector. And now a2 minus a1, your a2 minus a1 is a2 minus a1, that is this minus this is equal to this vector minus this vector. So this is equal to this minus this, 2 minus 1 I cap minus minus 3 j cap and minus 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 2 k cap. So here now your d will be equal to dot product of this is b1 vector cross b2 vector. So this is b1 vector, this and this, dot product of this I j j k k. So this is minus 3 and this is 0 and this is minus 2 3 is 6 divided by modulus of this. So modulus of b1 vector cross b2 vector is equal to root over 9 plus 0 plus 9, that is 9 this will be 18, 18 means 9 root 2, this will be 9 not 9 3 sorry, 3 root 2, this will be 3 root 2. So 3 root 2, so this is equal to d is equal to minus, that means 9 by 3 root 2. So this will be equal to 3 by root 2. Let me check the answer. That is question number 14, 11.2, question number 14. When you rationalize it, that is 3 root 2. by 2. This is your answer. So it is correct. Now here you see 15, 16 and 17. It is the same procedure you have to follow. Here in 15 your B1, in 15 your 15, I'm just you can solve it yourself. I'm just locating the points, that is in question number 15. In question number 15 here you see question number 15, you can do it yourself. Here your a vector is minus I cap, uh, minus j cap minus k cap. This is a1 vector, and your a2 vector, that is your 3I cap plus 5j cap plus 7k cap, and your b1 vector, this is your 7I cap minus 6j cap plus k cap, and your b2 vector, that is I cap minus 2j cap and plus k cap. I have just found it out. Now you can apply this formula. D is equal to modulus b1 vector cross b2 vector, then dot a2 vector minus a1 vector, and by magnitude of b1 vector cross b2 vector. You apply this formula, you can solve it. Because I have located all the points, your a1 that is minus I cap minus j cap minus k cap, and your a2 is, that is 3I cap 5j cap and 7k cap, and this is b1 is 7I cap minus 6 k cap, and your b2 is minus 2 1k cap. Now you can solve 16 and 17. It is like 14. You can solve these questions. So this is this exercise is over here about the equation of the lines in space.